SpaceX has just released the newest generation of the Starship and its booster, all in preparation for the 6th test flight in November. These shiny, fashionable models bear some differences from those used in the 5th test flight, and you will definitely be intrigued. What makes these new ships different from the previous generation? Could they perform even better than the last generation used in the 5th test flight? And what is SpaceX's next big plan for the Starship? I've got all the answers right here in today's video. Let's jump right in. The new Starship. SpaceX has just rolled out its newest Starship, Ship 31, to the launch site in preparation for the 6th test flight. While the ship is nearly ready, a few final adjustments are needed to ensure it's as impressive as the 5th flight. Following the success of Starship's 5th flight on October 13th, SpaceX is wasting no time preparing for the 6th flight, currently targeted for November 11, 2024, exactly 4 weeks after the previous launch. Before we dive back in, don't forget to subscribe and share this video with your fellow space enthusiasts. By joining us, you'll get the latest updates on every mission, breakthrough, and discovery in space. So, if you're excited to explore the cosmos together, give this video a thumbs up. On September 18th, SpaceX rolled out Starship 31, the next generation ship following Ship 30, which was used in Flight 5. The new ship was moved to the launch site in preparation for a static fire test of its Raptor engines, an essential preliminary step to confirm readiness for a 6th test flight. The Super Heavy Booster, designated B13, which will carry Starship 31, was deployed just 9 days after the test flight on October 13th. Similar to why Ship 31 was rolled out in September, Booster B13 was mounted on OLM-A for performance tests, including a pneumatic proof test, a cryogenic proof test, and a static fire test. Let's dive into the details of these critical tests. B13 and S31 tests. Ship 31, recently completed in the Rocket Garden, was transported to the Massey outpost for its static fire test on September 18, 2024. Standing 164 feet tall, this impressive vehicle gleamed with its stainless steel exterior. Although its heat shield was still incomplete at the time, it was a striking sight. Mounted on OLM-A, Ship 31's static fire test ran smoothly, with all 6 Raptor engines igniting successfully. Although SpaceX and Elon Musk have not provided updates on the test, it appears to have gone well. Ship 31's booster, designated B13, was also mounted on OLM-A, previously used for the 5th test flight on October 22nd. 3 critical tests were performed on this booster: a pneumatic proof test, a cryogenic proof test, and finally, a static fire test. During the 5th test flight, Booster B12 did suffer a methane gas leak, which sparked a fire at the base of the booster. While the exact cause is unclear, it likely resulted from the intense heat of the launch. Fortunately, Booster B13 showed no such defects, no leaks or structural flaws were detected. The cryogenic proof test was conducted to ensure the booster can withstand the bone-chilling temperatures and pressures it will encounter in space. To simulate these extreme conditions, engineers filled the tanks with ultra-cold liquid nitrogen instead of explosive propellant, then monitored how the metal structure coped with the intense contraction without the risks associated with combustibles. Like the pneumatic proof test, this test involved pressurizing the tanks to launch level extremes to reveal any leaks, warps, or cracks that might need to be addressed before launch. Booster B13 passed this test as well, demonstrating it was ready to take on the final challenge, the static fire test. On October 25th, a vertical Raptor engine test was conducted on Starbase's tripod stand, which assessed the engine's thrust power. Remarkably, a horizontal test was also performed, which is quite rare at Starbase. In total, the same Raptor engine was fired over 50 times throughout the testing period, with 34 of those firings occurring in just 1 day and within a single hour. Additionally, a Raptor 3 engine was brought out, likely for testing purposes, although there has been limited information released about it. What makes them different? You might be wondering what distinguishes the new Starship and Super Heavy models from those used in the 5th test flight and earlier versions. Well, there are some notable differences. Before diving into that, it's interesting to note that Starship Flight 5 could have actually taken place a day earlier. The launch on the 13th almost cost SpaceX dearly. During a live stream of a game of Diablo, Elon Musk received a call from the Super Heavy Booster engineering team, who were in a meeting at the time. Here's a clip of that audio.
We had a misconfigured spin gas support that didn't have quite the right ramp-up time for bringing up spin pressure, and we were 1 second away from that tripping and telling the rocket to abort and try to crash into the ground next to the tower.
The misconfigured gas support systems referenced by the team likely pertain to the spin start system on Booster B12. During the landing phase of the booster, there was reportedly a software malfunction that could have jeopardized the entire landing procedure. The misconfigured gas support systems referenced by the team likely pertain to the spin start system on Booster B12. If you listen closely, you can hear the engineer mention that they considered aborting the landing and allowing the booster to crash. In that scenario, the Super Heavy would have potentially crashed into the Mechazilla tower or come close to the shore. Additionally, SpaceX is focusing on the heat shield tiles of Starship to determine what caused the loss of tiles on Booster B12 during the 5th test flight. You may recall that during the ship's re-entry, it lost several tiles, causing the exposed areas to glow crimson and then red from the intense heat. The main questions surrounding this issue are whether the adhesive materials were improperly applied or if the adhesives used were not the most suitable for the tiles. During the static fire test of Starship 31 at Massey's, we observed that some areas of the Starship still body were not covered by heat shield tiles. While this could simply be due to the tiles not being fully installed yet, there are speculations that SpaceX intentionally wants to leave a few strategic spots uncovered. The reasons for this could involve data collection or a better understanding of the heat shield's performance and the ship's durability. As for the Super Heavy booster, SpaceX is planning several modifications. We've discussed changes to the cowbells and the proposed shortening of the Mechazilla chopstick arms, but there may be additional modifications in the works. The booster engineers will need to focus closely on the attachments used for various parts of Booster B13, especially in light of the incident during the 5th test flight when a piece of one of the chimes tore off the booster during the landing burn. Had it been any more severe, the booster could have crashed into the Mechazilla. Although this feature may not be present in the current design of B13, SpaceX plans to increase the number of Raptor engines from the current 33 to 35, effectively boosting the thrust power of the booster. There is also speculation about the potential debut of the Raptor 3 engine in B13. The hot staging ring used in the 5th test flight was recently recovered from the Gulf of Mexico. Unlike previous scenarios where the ring had fallen apart, this time it was recovered intact. SpaceX may consider reusing this ring for their 6th test flight, although they will need to make significant modifications and adjustments to ensure its durability. Let's end the video with an interesting event. SpaceX is currently working on a plan to build an orbital refueling system for the Starship once it is ready. This stems from the fact that the Starship uses almost all its fuel for around the Earth orbit. Thus, for missions like the Polaris mission and the Artemis program, the ship would need to be refueled in space multiple times. Here's where it gets even crazier. For the Artemis 3 mission, where the Starship will perform its first crewed flight to the Moon, there would need to be more than 10 extra Starships, probably up to 15 even, just for refueling. We've come to the end of this video, and if you enjoyed it, hit the like button, share it with your friends, and subscribe to Space Minds for the latest updates on our space news and adventures.